Hey, in this video, I'm going to go over solving word problems using linear equations. And if you're thinking, who cares? um, that is not the right answer, but I like your spirit. So, say we get a word problem. Two cell phone companies. One charges $42 a month and 5 cents for every megabyte of data used. And the other charges $36 a month plus 6 cents for every megabyte used. What does that tell us? I don't know. But part A, where there's 4 parts to this, but part A is asking us to write linear equations for each monthly plan. Okay, so what is a linear equation? And why did I capitalize it? I don't know. But a linear equation would be y equals mx plus b, right? Just like we've been doing. Okay. So how do we figure this out? How do we put these words into an equation? Well, first of all, for each monthly plan, so there's 2 cell phone companies, right? So we got, first of all, we just need to come up with names for them. And let's face it, we're in math class, we're not very creative. We just call it company A and company B. That's all we need to do. All right, so company A, let's say it's the first one. Okay. Company A charges $42 a month. Okay, so we can write that down, $42 per month. All right. And 5 cents. Why did I stress the word and there? Well, and can have multiple meanings. And 5 cents per megabyte used. Okay. Okay, so and now we're talking about the other company. Okay, the other charges $36 a month. $36 per month. Okay. Plus, there's a key word there. 6 cents for every megabyte used. So 6 cents per megabyte. That's what I like to do every time I get a word problem. I like to just write down what they tell me, all the big stuff. Okay, we got 2 cell phone companies, 1, 2, got it. One of them charges $42 a month, got it. 5 cents for every megabyte used, okay. That's it. That's all the information they gave us on company A. And the other one, company B, charges $36 a month plus 6 cents for every megabyte used. Wow, that plus seems like it's important. So maybe we're adding them together. We are. Just like there's a plus in the good old slope-intercept form. Now, write linear equations for each monthly plan. The key word is monthly. Look at this, $36 per month. So we know that we are going to have to pay at least $36 every month for company B, no matter what. Right? That makes sense. So let's just say company B monthly charge will be $36 plus 6 cents for every megabyte used. Now, we got to figure out what our variable is. We've already figured out what y is. Y is what we're trying to find, the monthly cost. B sub m, yeah. I put B sub m because it's company B and it's the monthly bill that they're going to charge. So they're charging $36 plus 6 cents. Okay, wait a minute. Slow your roll. When you're putting these numbers into an equation, they need to be in the same unit. You know what I'm saying? A unit would be the type of number that it's representing. So this is cents and this is dollars. Those are different units. We need them to be either both dollars or both cents. Let's just have them be both dollars and put 0.06 for 6/100ths of a dollar. That would be 6 cents. Now, the variable is megabyte used. It's got to be, right? Megabyte of data used, because that really depends on the month, doesn't it? So X is megabytes used per month. All right, once you've established that, this becomes a lot easier. This is basically just like our slope-intercept form, only you just got to reorder it a little bit. Got our intercept right there and our slope, 0.06. Wow. That wasn't so bad. Well, that's one equation. That's what they wanted us to find linear equations. We found one. All right, what's company A? A's monthly plan, 5 cents per megabyte. Got to remember to convert that to dollars per megabyte. Plus 42. Not too shabby. Now, you might have some teachers that are, anti-decimal. So maybe we want to convert this to a fraction. Say 5/100ths, right? Plus 42. That might look a lot better to a teacher. You never know. They might appreciate that. I mean, because your slope is rise over run, right? So why not put it in a fraction? Just easier. Easier for later on, but that is next. We found our answers. Company A's monthly bill, Company B's monthly bill. They have linear equations representing that. So if we were to graph these, they would actually be lines that just go up at a steady rate, They would actually not be very steep, right? Because rise over run, they would run to the right 100 steps and then go up 5. So they would be more like that. And this one would just be just a little steeper, like boom, like that, But that's just visually picturing it. All right. All right, let's get into part 2, or part B. So our question is, if 1.1 gigabytes of data is used per month on average, which is the better plan? Well, first of all, what are they asking for? They want which company charges less if you use 1.1 gigabytes of data every month. On average. I mean, it's going to be variable depending on the month, but if you're a family that uses a lot of data, maybe you want to know which plan is better for you. So we take our answers from part A and we just substitute in our variable to see which one gives us a lower value, right? But wait a minute. They say gigabytes here. Our formula is in megabytes. So first thing we got to do is switch 1.1 gigabytes to megabytes. How do we do that? Well, there's a thing called conversion math, which I love to do. You just kind of multiply something by a fraction and you cancel out the units until you get the unit that you want. So we want megabytes. We have gigabytes. We know there's 1 gigabyte in how many megabytes? I had to look this up just to make certain I knew what I was talking about. 1,000 megabytes in 1 gigabyte. So when you divide gigabytes divided by gigabytes, they cancel out, right? It's like 3 divided by 3. It's just going to be 1, right? And you're left with megabytes. So 1.1 times 1,000. You just kind of move that decimal over 3 times, right? And you add zeros in there, so you get 1,100 megabytes. Now, what do we do with that? Well, the data is our variable, right? So we simply just put that number in there and evaluate it to figure out what A sub m is, and put it in there too to figure out what B sub m is. A lot of teachers use the word substitute, but I prefer plug it in. So anyway, the company A monthly bill for 1,100 megabytes of data would be what now? Whew, okay, well, I'm glad I changed this to a fraction because this makes it a little easier, right? Because you can kind of divide that out, right? So 1,100 divided by 100 would just be 11, right? 5 times 11 is 55 plus 42. All right, 55 plus 42. 5 plus 2 is 7. 5 plus 4 is 9. $97 for company A. All right. That's the mark to beat. Company B. 6 over 100 times 1,100 megabytes plus 36. Okay. Same thing, divided by 100. We get 11 times 6, which is 66 plus 36. Ooh. This might be a little tougher on the addition master. 6 plus 6 is 12, right? Ooh, okay, so 7 plus 3 is 102. $102. Whew. That's for company B. So which one is better? Company A. And that's the answer to part B. All right, now part C. Now we have a different question. If the average data used per month is 500 megabytes, which plan is better? Same thing we just did, but they didn't give us gigabytes this time, so at least we don't have to convert it. And we just plug them in again. So company A would charge 5/100 times 500 plus 42. Okay. Well, 500 divided by 100 is 5. 5 times 5 is 25 plus 42, right? So company A would charge $67. Okay. Company B. What do you got for me, company B? 6 over 100 times 500 plus 36. Okay, 100. 500 divided by 100 is just 5. 6 times 5 is 30. Plus 36. B would charge $66. Oh, so close. But I'm going to have to give it to company B this time. All right, part D. We're almost done. This is the last question. Got all my answers written out here. Part A, part B, part C. So, what do they want to know now? How much data would yield equal monthly bills from both companies? What? How do we figure that out? Well, remember in part A when I told you that both of these companies, these linear equations, they have slope and y-intercepts. Well, if you remember from my parallel and perpendicular lines video, are these parallel? No, they do not have the same slope. Are they perpendicular? No, they don't have the negative reciprocal of the slope of the other line. So eventually they will intersect because they're not parallel. Forget the thing I said about perpendicular. Perpendicular lines do intersect as well, but they intersect at a very specific angle. These will be a very small angle or a very large angle, depending on your point of view. But we want to know where they intersect, because where you are at on that line on this graph is your monthly bill, right? Wherever you're at on the lines is your monthly bill. So we want to know where they intersect. Well, how do we figure that out? Well, there's a neat little trick to figuring out the intersection. Have we talked about intercepts yet? Whenever you want to figure out when a line intercepts the y-axis, what do? You set x equal to 0, because x is 0 all along that y-axis. And the same thing with finding the x-intercepts. You set y equal to 0, because y is 0 all along that x-axis. So how is that going to clue us in to find the intersection? Well, you kind of just substitute the other equation in and figure out where they line up. How do we do that? Well, if company A's monthly plan is 5 over 100x plus 42, and company B's monthly plan is 6 over 100x plus 36, we want to find how much data, that's what they're asking. We could just take this equation and this equation, set them equal to each other, and that would get rid of our monthly bills, because we're basically saying we want to know where this monthly bill is the same as this monthly bill. And we're saying A sub m is equal to B sub m right now. And that's why we can just take this and set it equal to that. And then solve for x. What? Crazy. I know. Well, let's get to solving for x then. Let's get x over on the left. Subtract 6/100ths of x. Subtract 6/100ths of x. So we get negative 1/100th of x plus 42 equals 36, right? Because this canceled out. Subtract 42, subtract 42. Let's move this over here. Rewrite. Negative 1 over 100 times x equals 36 minus 42. Ew. It's going to be negative. Well, let's just do this over on the side here. 42 minus 36. 12 minus 6. 6. Okay. Oh, well, that was easy. But it's negative. Remember, because 42 is larger than 36, and we just subtracted from it. So we got negative 6 over here. So to get x by itself, we got to multiply both sides by negative 100. Wow, okay. Cancels, doof doof. Double negative becomes a positive, and 6 times 100 is 600. Don't forget your units. They wanted how much data? We found how much data, 600 megabytes. And that is your answer for part D. So do you understand that? The monthly bills will be equal. So that's why we can set A sub m equal to B sub m.